So, very good morning. Today, we will discuss about minimum cost spanning tree. MST stands for minimum cost spanning tree. So, this is a tree how to construct minimum cost spanning tree with the help of Prim's algorithm and Kruskal's algorithm we will discuss in this online lecture. Before discussing about Prim's algorithm and Kruskal's algorithm, we will discuss about the differences between tree and a graph and what is spanning tree. What are the applications of spanning tree? How to minimize the cost of a given spanning tree with the help of two algorithms, familiar algorithms, Prim's and Kruskal's, and their time complexity analysis we will discuss in this lecture. Now let us move to the topic minimum cost spanning tree. So this topic is to be defined or solved with the help of by using greedy strategy to construct the tree. Here, the difference between tree and graph will be clearly mentioned in the slide. What is a tree? A tree is a non-linear data structures. Basically, there are two types of data structures, namely linear data structures and non-linear data structures. In linear data structures, we usually use creation of stack and creation of queue, whereas in non-linear data structures, we use trees and graphs. So this is very important, the difference between tree and a graph. A tree is a non-linear data structure in which it can be shown like as a hierarchy model. Assume that this is the tree. The tree seems to be like hierarchy model. Here the hierarchy in the sense level 1 there is a node called A. Level 2 there are two nodes called B and C. And level 3 there are three nodes namely D, E, F. Here A, B, C, D, E, F are considered as nodes of the tree or vertices of the tree. These A to F are considered as nodes or vertices of the given tree. So the tree is a connected cyclic graph. In the tree, each and every node or vertex is connected by a straight line that is called as edge. Here the vertex is connected to vertex B and vertex C. There are two edges are formed. A to B is one edge. A to C is another edge. These are represented as edges of the given tree. The tree with n nodes contains exactly n minus 1 edges. This is the thumb rule. Consider the tree. How many nodes are there or vertices are there? There are 6 vertices or nodes are there, namely A, B, C, D, E, F. Total number of nodes or vertices of the given tree are 6. But the tree can contain how many number of edges? N minus 1 edges the tree can contains. How it is, we can simply apply the formula n minus 1. Consider the tree, there are n nodes. If the tree can contain n number of nodes, exactly n minus 1 edges are available. So that means that 6 minus 1, 5 edges are available. What are the 5 edges here? A to B is 1 edge, B to D, B to E, A to C, C to F. These are 5 edges which can be came from the given tree. So next we move to another one is graph. What is graph? A graph is a connected one. Graph with n nodes contains less than or equal to n into n minus 1 by 2 edges. Now we will broadly describe the concept of tree here. So this is the given tree. The tree data structure is a non-linear data structure. So why I can say this is a non-linear data structure? Because there are various levels. It seems to be hierarchy level. Level 0, level 1, level 2, level 3. Total 4 different levels. It seems to be like a non-linear data structure. Hierarchy will seems like a non-linear data structure. A tree, basically the definition of a tree is a collection of nodes that are linked together to form a hierarchy. Here, there are a collection of nodes, namely node A or vertex A, vertex B, vertex C, vertex D, vertex E, vertex F, G, H, I. These are considered as vertices or nodes of the given tree. A tree is a special form of a graph. It is a special form of a graph that is minimally connected graph and having only one path between any two vertices. If you consider the vertices, A is one vertices and B is one vertices, and the distance between vertices A vertices B is considered as a path. This is considered as a path. The path can be considered for any two vertices. Tree is a special case of graph which is having no loops, no circuits, no self loops. This is the condition. If you consider any tree, there should not be any cycles. Cycle should not be formed in the tree. No loops also not formed in a tree. No circuits also, circuit in the sense here, circles, circle is not formed. And no self loops also, A to A, this is the self loop. A to B, this is a loop. And B to C, if you consider B to C, there is a cycle will form. That is not considered as a tree. So the tree can not have loops, circuits, or self loops. In a tree, there is exactly one root node and every child having only one parent node. Consider this is the tree. The tree can contains only one node. The topmost node of the tree is considered as a root node, or vertex of A is considered as a root node. And here, this circle, in the circle, there are three nodes. So, namely, this is called as a parent node, and H is called as a child node, and this entire tree is called as a subtree, and I is called leaf node. There are different types of trees. We have seen binary trees, binary search trees, AVL trees, and heap trees. These are different examples of the given tree. What are various applications of the tree is clearly mentioned here. Generally, trees are used to sorting, searching, like binary search tree, or quick sort, merge sort, etc. How many number of edges a tree can contain? There are n number of edges a tree is always can contains. If you see the structure of the tree, it seems to be like a hierarchical model. Why? Because it seems to be a level 0 to level 3, different levels. So this is the description about tree. Next we will discuss what is a graph. A graph is also considered as a non-linear data structure that collects vertices and edges. Here there are five vertices, namely vertex A, vertex B, vertex C, vertex D, vertex E. These five circles are considered as vertices, and we can connect any two vertices. Thus, T is called as a edge. Here we are connected B and E with a straight line. The vertex B is connected with E with the help of the edge only. This is considered as a edge. And the tree, given tree can contains how many number of nodes or vertices? 1, 2, 3, 4, 5. There are 5 vertices. There are 5 vertices here. So in the graph, this is the graph. In the graph, there can be more than one path. That is, graph can have unidirectional or bidirectional paths between nodes. Here, A to B and B to A. You can move from A to B and you can come back from B to A. That means that it is not a, there is no direction specified here. So it can be considered as a bidirectional. It can be considered as a bidirectional. Why? Because we can move simply from A to B or come back from B to A. There is no arrow marks are clearly specified. So the graph can be bidirectional path between two nodes is possible. In graphs, there is no such concept of root node. Consider this is the graph. The graph cannot contain any root node. You always consider any node become the starting node. Randomly you can select any one of the node. So there is no concept of root node in the graph. Graphs cannot have loops, circuits in the sense circles, as well as self loops. Always remember that a graph cannot have any loops or any circuits, as well as cannot have self loops. If the graph can have loops or self loops, we can automatically remove them. In graphs, there is no such parent-child relationship. Why? Because here there is no concept of root node. If the root node concept is not applicable here, there is no point of view to provide the relationship between root node and the parent node. Hence, parent or child nodes are not considered in the graph. Graph is traversed by DFS, depth first search, and BFS, birth first search. There are mainly two types of graphs, namely One is directed graph, another one is undirected graph. And what is meant by directed and what is meant by undirected graph, we will discuss in next slide. So, what is the best example for graph is Facebook. A Facebook application or a Facebook is a social network that uses the graph data structure. Facebook is one of the familiar example for the graph. Why? Because there is a relationship between among one person to another person. Through network, social network, a huge network will be constructed through the help of the graph. It is mainly used for finding the shortest path in the network. So basically, the applications of graph is finding the shortest path in a network. Consider this is the network. If you want to connect, establish a well-connected network among those nodes, so always you can find the shortest path network. And also mainly used the technology of graph for coloring of a maps as well as graph coloring problem and solve the job sequencing with deadline problem. So to solve these applications, we use the technology of graph. So here we clearly described the difference between graph and tree. Both are considered as a non-linear data structures, but in the graph there should not be any loops, whereas in the tree there should not be any loops. So some of the representation of the graphs shown here. Consider a graph is represented as G, capital G is the graph, and the capital G graph can contains vertices. How many vertices? A collection of vertices, namely the name of the vertices are 0, 1, 2, 3, 4. These are considered as vertices. And edges also, here there are edges, namely 0 to 1 is one edge, 1 to 2 is another edge, 2 to 3 is considered as an edge, 1 to 3 is another edge, 1 to 4 is another edge. So the graph can contains n power n minus 2 number of edges. So in this way we can represent the graph. So there are two different types of graphs. If if you consider the figure out here, there is a difference between undirected and directed graph. What is mean by undirected graph and what is mean by directed graph? The main difference is there is a clear identification of source and destination. If you consider the undirected graph, there is no possibility of considering source node and destination node. Why? Because here you can move from A to B or B to A. So vice versa, we can move from A to B or B to A. But if you consider this directed graph, you can move from A to B only. There is no provision from moving from B to A. Why? Because here the direction will be clearly indicates from vertex A to vertex B only, and there is no provision from vertex B to vertex A. So that's why it is clearly indicates that the difference among undirected and directed. So directed graph is considered as a source and destination point of view. Whenever you are planning to construct a tree, minimum cost spanning tree, you can use directed graph. And here, this graph is considered as a weighted graph. Weighted in the sense cost of the each and every edge. The cost of each and every edge will be clearly mentioned with red color cost here. Consider there are vertices, namely 0, 1, 2, 3, 4, 5. These are vertices, and we can connect any two vertices through a edge. This is the edge. 0 to 1 is one edge. 1 to 3 is another edge. Like this, many edges are there. The edges are clearly indicated as a directed mode. That's why we can consider this is the directed graph only. But we cannot say it is a directed graph. It is considered as a weighted graph. Why? Because each and every direction there is a path, and the path is having a cost. Here, the cost of the path from node A to node 0 to node 1 is 4. That means that clearly indicates the distance among vertex 0 to vertex 1 is 4, vertex 1 to vertex 3 is 2. Like that, so the weighted graph will be constructed. There are different types of graphs we have seen. So some of the familiar graphs, well-noted graphs listed over here, namely undirected graph, connected graph, and directed graph. Undirected graph in the sense there is no arrow marks, there is no directions, clear directions from source to destination. That means that an undirected graph is a graph in which all the edges do not point to any particular direction. So that is they are not unidirectional, they are bidirectional. So always undirected graphs are considered as a bidirectional. We have a provision to move from one vertex to another vertex, either forward or backward direction. So that's why we can consider this is a bidirectional graphs. Whereas it can also be defined as a graph in which the set of V vertices and set of E edges, each edge connecting two different vertices, that is called as a unidirected graph. Whereas connected graph in the sense a connection graph is a graph in which a path is always exist from a vertex to another vertex. That means that there is a path among from one vertex to another vertex, and we are giving some cost of the path also. So if you want to connect any two vertices, you can use a edge that is called as a connected graph. Whereas the directed graph is a graph that is defined as a graph in which the set of vertices and the set of edges each connecting two different vertices, but it is not mandatory that node points in the opposite directions. Also, directed graph in the sense there is clearly mentioned the way we can move from source to destination. It is not a bidirectional. So this is called as a directed graph. So friends, we discussed the difference between tree, graph, and what is this and what are wedges and what are weighted graphs, connected graphs we discussed as of now. Now let us discuss the concept of spanning tree. What is a spanning tree? The mathematical point of view, we can define the spanning tree as if we have a graph, the graph is G, and the graph can contain vertices and edges, then technically in the mathematical point of view, we can consider the graph can be represented as G of V comma E, where is G is a graph and contains a collection of vertices V and edges E. If we create a spanning tree from the graph, if you want to create a spanning tree from the given graph, then the spanning tree would have the same number of vertices as the graph can contain. But the vertices are not equal number of vertices. The edges in the spanning tree would be equal to number of edges in the graph minus 1. That means that consider any spanning tree. In the given spanning tree, the calculation of number of edges will be depends on the total number of vertices. The edges of a spanning tree is considered as total number of vertices in the spanning tree minus 1. Suppose the spanning tree is represented as G dash V dash E dash, whereas V equal to V dash and E dash belongs to E minus 1, whereas E dash equal to V minus 1. That means that the total number of edges in the given spanning tree equal to the total number of vertices the graph can contain minus 1. In this way, we can calculate the total number of edges in the given spanning tree. So this is the way of generating different possibilities of spanning trees from the given graph. Consider this is the graph. I already told that a graph is a collection of nodes and edges which are interconnected together. So total number of vertices are four, namely vertex A, vertex B, vertex C, vertex D. The total number of vertices are 1, 2, 3, 4. From the four vertices, we can generate three different number of spanning trees are generated. But here, the spanning tree which can be generated from the given graph are satisfying some conditions. That is, the the tree cannot be cyclic. So this is not a cyclic one, but almost it will be covered. This is the way we can create another spanning tree. This is another way we can create spanning tree. So we can create different possibilities of spanning tree from the given graph, which can be satisfies the condition that is cycle cannot be formed. Cycle cannot be formed. And also we can connect one more graph A to B, B to C, C to D also. So this is also considered as a spanning tree. The definition of a spanning tree is a spanning tree of a graph G is a tree that covers all the vertices using minimum number of edges. The spanning tree cannot have any cycles. That means that cycle cannot be found for the spanning tree. And the spanning tree can contain n number of edges, where n is the number of vertices. Suppose the spanning tree can contain four vertices, namely A, B, C, D. Total number of edges is three edges, n minus 1, 4 minus 1, three edges are found. Here A to B is one edge, A to C is the second edge, and C to D is another edge. Total number of edges will be always depends on the total number of vertices of the given graph. So total number of edges in the given spanning tree equal to V minus 1. Total number of vertices minus 1. So the graph can have more than one spanning trees. So the given graph can have three different spanning trees. In fact, a complete graph can have a maximum of n power n minus 2 spanning trees. So total number of spanning trees can be generated from the given graph is n. Here n is 4, 4 power 4 minus 2. That means that 4 power to 16. So there is a provision of creating 16 different spanning trees from the given graph. So in this way we can generate a many number of spanning trees. And friends, here why we use spanning trees, what is the basic idea of spanning trees? Why we really use spanning trees, which clearly states the applications of the spanning trees here. So the applications of spanning trees are, the first one is civil network planning. So in the constructions of buildings, we use spanning tree technology, whereas the construction of land or the designing of land, we want to design a local area network, which means that many desktop or internal computers which are connected to a single server In this case, a network will be formed. That network will be structure will be designed by using the tree. That tree is considered as a spanning tree. So here, whenever you are planning to designing any local area network, there should not be form a cycle. Each and every node or vertex in the tree should be well connected together, but cycle should not be formed. So designing of a LAN is another application. Another one is computer network routing protocol. If you want to establish or design computer networks among different routing protocols, we use the spanning trees. Another example is cluster analysis. Cluster analysis is nothing but in the sense a collection of inter networks are called as a clusters. A cluster will form a huge number of networks into a single place. That cluster analysis is also one of the common application of spanning tree. Another one is laying pipelines connections. So whenever you are planning to construct a house, at that time we need to lay the pipeline connection to the building. So the pipeline connection to the building should not form a cycle, but all the taps will be well connected to the root node. All the cap so in this way, if you want to set up a electric power, set up a water plant, or set up a telephonic line, or set up a sewage lines in our day-to-day life, or while constructing a house, we commonly use spanning trees. To reduce the cost, you can connect houses with minimum cost spanning tree. Why we need to construct or applying the spanning tree for our day-to-day life is to reduce the cost. Now let us consider a simple example for considering or constructing a spanning tree here. Let us understand this through a simple example now. Consider a city. The city network has a huge graph. If you want to construct a network among the city, assume that there is a huge network graph is required. And now you can plan to deploy the telephone lines in such a way that in minimum lines which we can connect all the city nodes. So this is where the spanning trees comes into the picture. That one means that consider a city, a Hyderabad is the city. If you want to establish a trusted uh, line connection, trusted mobile line connection or landline connection or telephonic line connection, always we should depend on the concept of spanning trees. If you apply spanning tree technology while constructing the telephone line networking in the city, any one of the city like Hyderabad, so you can able to construct the cable network with minimum number of cost only. So that can be possible through the application of spanning tree using greedy strategy. So this is the clear picture showing that the telephonic wires laying among different cities. So consider, so this is the central office. Assume that this is the BSNL central office. There are various offices or residences which are located in different places. So if you want to establish a well-connected network among those offices or residential floors from the centralized office, you need a structure. You need a structure. That the structure clearly designed, and the structure can be designed in such a way that the minimum cost spanning tree is to be constructed here. So minimum cost is required. You need to establish the connection among all the offices or residents, but the main motto or main objective is connect all the networks to minimize the cost only. So here there are two different ways we can connect. So from the central office, we can connect directly all the possible or available ways. This is the this is one of the way of connecting the telephonic connections. So from the central office, I can connect direct connection to each and individual houses or offices. This is one way of connecting or establishing the telephonic wires connection. So it is expensive. Why? Because each and every node or each and every node is to be well connected to the central office. So this is the cost expensive, and this is not suggestible. But to minimize the cost, we need to follow one algorithm that is called as the Prim's algorithm, whereas we can consider as a Kruskal's algorithm. So by applying Prim's and Kruskal's algorithm, we can easily minimize the total length of the wire connecting to the customers. Whenever we are applying minimum cost spanning tree technique to the given problem, so this is the solution. So here there is a central office. In the central office, first we can find out the less distance place, which one is less distance, we can connect it first. Next, we can connect it another one. So this is the less distance. So from central office to here, this is the another less distance. And likewise, we can connect here. But here, cycle should not be formed. So here, the structure is seems to be this is the hierarchical structure, but cycle cannot be formed. So in this way, we can connect the networking among different cities. So the best example for applying minimum cost spanning tree is telephonic line wiring networking for LAN WAN in any central office. Now here we will discuss one more example of applying minimum cost spanning tree. So consider this is an example. Here there are various villages or cities, namely A, B, C, D, E, F. This is A. A is one city or one village name. This is B, another village name. This is C, another village name. This is D, another village name. And this is E, another village name. And this is F, this is another village name. So total number of villages are 1, 2, 3, 4, 5, 6. There are 5 different villages. The main problem is a cable telephonic company want to connect 5 villages, want to establish a connection among 5 villages A to B, C, D, E, F to their network, which currently expand to the market town of A, starting from A. And what is the minimum length of the cable needed? This is the question. That means that so there are 6 different villages, namely A, B, C, D, E, F, and each and every village is well connected together with a pair of distance. The distance between the village A to village B is 3 kilometers. The distance between village B to village C is 5 kilometers. And find here what is the minimum length of cable is required, in the sense we want to find the minimum length of that cable required to establish the connection among all the cities, that can be clearly described or designed with the help of the algorithm. One is Prim's algorithm, another one is Kruskal's algorithm. If you apply Prim's or Kruskal's algorithm to the given problem, we can easily find the solution for that. Next, we will discuss about minimum cost spanning tree. What is mean by MST? MST stands for minimum cost spanning tree. Why we use minimum cost spanning tree in the market or in our day-to-day life? We use minimum cost spanning tree to measure the shortest distance or path among any two different cities or any a network of cities. If you want to find the minimum cost or distance among two different cities or in the networked cities, we can use this minimum cost spanning tree. And if you want to establish a land local area network, so among different cities or among in a house or in a home, you use minimum cost spanning tree. If you want to establish or construct a well-structured pipeline network for an apartment, you can use minimum cost spanning tree. And also, if you want to establish a telephonic network among different cities or in a city with different houses or residential properties, we can use the concept of minimum cost spanning tree. Basically, the minimum cost spanning tree problem works on the principle of greedy method with the help of the two algorithms, namely Prim's and Kruskal's algorithms. So the minimum cost spanning tree problem is can be solved by using greedy technology. Here, the problem can be solved using greedy technology. We can focus on two algorithms, namely one is Kruskal's algorithm and another one is Prim's algorithm. So by using Prim's and Kruskal's algorithm, we can clearly identify the minimum cost spanning tree of the given problem, and we will discuss the Prim's and Kruskal's algorithm in the next class. Thank you. Thank you.